All right, so doing a lightning talk on machine learning because I think it's a pretty neat topic. So there's a lot of reasons why I think it's important to learn about machine learning. I'm only going to talk about two in particular. Number one is it's just really cool. This is the sort of thing that Matt Nixon and I send each other on Slack. We'll be like, hey dude, did you know some researchers like hacked a neural network such that if you give it a picture of just a regular photo and a famous painting, the neural network will repaint that photo in the style of that painting. And we're just like, dude, that's nuts. And we're just like, we just lose it. So if you look at our chat history, that's all it is. The other reason is as we get more into this space, we need to be aware of this quote. I don't care if it's a developer or a BD or the client. If you hear the words just and machine learning in the same sentence, ask some questions because they probably don't know what they're talking about. So hopefully this talk will kind of arm you with the knowledge to know what questions to ask and kind of drill down a level deeper. So from a 10,000 foot view, you have AI and you have machine learning. So machine learning and artificial intelligence are not the same thing. Machine learning or artificial intelligence encompasses a lot of different things like natural language processing and machine vision. So it's just a subset of AI. Zooming into machine learning, there are three distinct categories. There's supervised learning, unsupervised learning, and reinforcement learning. So in the next 5 minutes, I'm going to maybe go down a level deep on each of these, show a cool example of what they are, and then we'll wrap things up. So first up is supervised learning. There's actually two different types of supervised learning. There's classification and regression. Don't really worry about memorizing those words. There's the predicting labels versus predicting floating point numbers. That's really the difference here. So the first one is classification. With classification, what you're doing is you start out with a whole bunch of training data and the corresponding labels for that data, and you're going to give it to some algorithm. Usually it's a neural network, and it's going to crunch through that training data and basically produce a black box that could make future predictions based on future inputs. So the classic example here is facial recognition. I have an example where I do this. So I did this last night. So I'm going to train it with 3 different types of images. And when it sees me, I want it to show a picture of a cat. So I can click train. It's a video of me, but it's taking a lot of different pictures of me to get used to what I look like. Then I'm going to show a picture of my daughter. And when it shows a picture of my daughter, I want it to show a puppy on the right side. So right now I'm training it with different images of my daughter. So this is just, here's a sample input, here's the labels. This is my wife. When it shows my wife, I want it to show a bunny. So it's training, getting a few different example images. And now when it shows my daughter, it should show the puppy on the right. When it shows me, it should show the cat. And it gives you the confidence interval. I show my wife, it'll show the rabbit. So that is a neural network. Give it a bunch of training data, give it the labels for that training data, and it'll make predictions for future input. If you want to play with that, there's a link up there, Teachable Machine with google.com. You'll see this in a lot of different areas. Your spam email filter probably uses supervised learning. That stupid mobile app where you take a picture of something and it says, is this a hot dog, yes or no? That's probably using a neural network. Whenever you use the postal service, and you're using handwritten address, it's doing optical character recognition. That's machine learning. That's supervised learning. The other example is regression. Supervised learning, again, the only difference here is instead of giving training input and labels, you're giving it training input and values, floating point numbers. So to get a good example of this is, here's a 1-bedroom house that's 1,200 square feet. The value for that is 124,000. Here's another house that's 3 bedrooms, 3,000 square feet, worth 275,000. It trains this black box model such that if you give it a new input, let's say a 2-bedroom house at 2,000 square feet, it'll say, I'm pretty sure this house is worth 237,000. So same idea, except you're just dealing with predicting floating point numbers. So you could use this sort of thing for predicting how much your house could sell for, or maybe you work on a product that does manages the back office of a restaurant and you want to predict how much lettuce you want to use on Saturday or need to order. Or maybe you're in marketing or in recruiting and you want to predict a certain salary for someone. Just anything like that is a good example of how to use regression supervised learning. Okay, then you have unsupervised learning. Unsupervised learning is you have the training data, but you don't have the right answer. So you basically want the machine learning algorithm to find some pattern in the data. So it's basically, here's some data, let's go find a pattern. There are a few different techniques. One technique that I'm going to go over is called clustering. So if I gave you this image to any human and I said, find some patterns in this data, most of us would be able to say, okay, I see there's 7 groupings. There's 2 clumps at the top, 3 in the middle, and 2 in the bottom. We can actually have the machine detect this for us using something called k-means clustering. So what I could do is add 7 random points to begin with, and there's just a really simple algorithm to go find the groupings here. I say go, and these are called centroids. You're not seeing this because I don't know why. Zoom quit unexpectedly. Well, that sucks. Hang on. Cool. So I have 7 centroids on here. I'm just going to blaze through this since that set me back some time. But basically, there's this algorithm that'll look at the distance between those centroids and the points, and these points will automatically move to the clumpings, the clusters that they've detected. So this is unsupervised learning for detecting patterns in data. This is just 2-dimensional data. Where's my keynote? So I actually use this on one of our projects for image processing. I start off with a color image and I grayscale it. I basically want to detect the light regions of a photo, but it's hard to do that when you have 3 colors. So just grayscaling it makes it so that there's only 1 color channel, but there's still like 200 shades of gray. So I use a clustering algorithm that says, turn this image that has 200 shades of gray into 5 shades of gray, and that's what the bottom is. And so now I could do, it's the same image, but with fewer shades of gray, and now I could do more image processing to say, okay, now it's a little bit easier to detect the light regions and the dark regions for whatever problem I'm trying to solve there. And then the last example is reinforcement learning. This type of learning is where basically a machine kind of teaches itself to do something, and it's typically done through kind of the carrot and stick strategy. So basically, when the machine is producing undesirable behavior, you kill it, and it gets garbage collected. When it's producing desirable behavior, it gets to not die and continue on. So that's basically it. The examples here, like this is how you teach a machine to play Go better than the best players in the world. You basically say, here are the rules of Go. You come up with a representation of a strategy for Go and play yourself a million times. And the strategies that do better persist and keep continuing and keep improving, keep varying until they get so good that they can beat humans. This is also how genetic algorithms work. So mimicking biological evolution, you can say, evolve an image that looks like Bugs Bunny smoking a cigarette, and you just press go and let it run for 20,000 times. And after enough times, the variance of the solutions that solve the problem better persist on. The ones that do worse just don't breed in terms of a genetic algorithm. And there you go. We have a genetic algorithm doing reinforcement learning. So again, at a high level, supervised learning is you have training data, you have the right answers, and you want to make predictions for future input. Unsupervised learning is you have training data, but you don't have the right answers, but you still want to find patterns in the data. And reinforcement learning is a machine teaching itself to solve some problem. So that's all I had. Are there any questions about machine learning? Yes.
What's the easiest way to get into high-level machine learning so that you can play with it without actually knowing how it's working, but just do fun things besides that learning thing?
I'd say it depends on which one. If you like neural networks and face detection, there's plenty of examples out there like the one I showed. There are services out there like TensorFlow. AWS has a machine learning service, so does Azure. So a hello world example in one of those services might work. Or come to my desk and I can show you some cool things, or Mixin too, he'll show you some cool things too. Brandon.
Any projects that you've worked on in Aperture where you felt like you should have used machine learning and missed?
I had been asked that question and I'm looking for an answer to it. So I will get back to you. Last question, then we'll get to Chris. Yeah.
So when you're going through choosing stuff like, for example, k-means or k-means, there were different algorithms you can choose to train machines. Do you find that there's some pretty well-defined, like the methods that should be used are pretty well-defined, or do you find that it's pretty much just a Wild West where everybody's just trying all this different stuff?
Well, the slide where I say just use machine learning, there are specific algorithms that solve specific problems. K-means is good for clumps of data. If you had a cluster of points right here and a ring of points around it, k-means would not be good for that because it basically finds the average position. So there are other algorithms based on the nature of the data. So there is some kind of unambiguity, I don't know the right word for it, but there's some kind of guidance for determining that. That's all I have time for, so thanks, and get to Chris.